It's no secret in the auto industry that significant changes in the battery supply chain will be required to meet manufacturers' commitments for EV production this decade. One of these is a much greater use of lithium iron phosphate or LFP battery chemistry, in addition to the nickel-rich chemistries currently used in many EVs. After a couple of decades in the car manufacturing industry, Ford is in the news with something bigger and better as the company is making a complete U-turn from traditional combustion engines to a full-fledged electric vehicle manufacturer capable of competing with Tesla, and we are excited to welcome Ford into the world of modern electric vehicles. Ford demonstrated that they mean business with a recent announcement of the type of battery they intend to incorporate. Is Ford working on more affordable electric vehicles with less expensive batteries? Stay tuned as we explain why Ford's new battery has shocked the industry and learn more about Ford's most recent battery breakthrough. Since 1903, when Henry Ford officially introduced their first model, Ford has been very competitive and a staple on American highways, and they have recently made some significant changes. The first change is the development of electric vehicles, which they intend to compete with other electric vehicle manufacturers in the market, particularly Tesla. And in order to truly compete with Tesla, they must produce cars that not only look beautiful and perform fantastically, but they must also be affordable. Ford seems to be ready to take on the task, as it stated back in 2021 that it was considering using LFP, primarily for commercial applications. It announced recently that there is a significant supply agreement with China's CATL or LFP cell supply beginning in 2023, which is surprising. During a recent Q&A session, Ford CEO Jim Farley stated that the company is working on incorporating lithium iron phosphate or LFP batteries into its first-generation electric vehicles, which include the Mustang Mach-E, F-150 Lightning, and E-Transit. Yes, since we've been working on LFP for quite some time, let's just leave it at that, Mr. Farley said. What I mean is that we see engineering LFP solutions in our first generation of products as a big opportunity to move quickly. According to a statement from Ford, this creates even more capacity for high-demand products and provides customers with many years of operation with minimal range loss. It also reduces Ford's reliance on some scarce critical minerals such as nickel and saves the company 10 to 15% on material costs. By selecting LFP batteries for their vehicles, Ford is putting themselves in a position to provide great products at a lower cost, which is part of Ford's DNA. Aside from the lower cost, there are other benefits of this lithium iron phosphate, such as the car lasting much longer, which indicates how many times the battery can be charged and discharged before its capacity drops below 80%, and as previously stated, LFP batteries have a life of 2 to 4 times longer. Would you rather buy a car that will last 10 years or a car that will last 20 years if you are buying a car? Most people, I believe, will make that obvious choice. Another advantage is that they do not cause a fire. There have been no reports of fires in vehicles equipped with lithium iron phosphate batteries. BYD, the world's largest battery manufacturer, has stress-tested LFP by drilling, dropping, and crushing them all with 0 fires. But the same test on an NMC will result in an instant explosion. The third benefit we will discuss is the lack of charging regulations. You may have heard that you should only charge your battery to 80% and not let it go below 20%, which is correct because it is an NMC battery. There are no rules with an LFP battery. You can charge to 100% and run it flat as many times as you want, lowering your ownership risk significantly. We've already discussed the advantages of the LFP battery, but what about the disadvantages? There is only one that we can think of. As it stands, the energy density is approximately 50% lower, implying that the range and charge they can deliver are 50% lower. To compensate for the loss in range, a car with an LFP battery is typically heavier because more batteries are used to compensate. However, LFP technology is rapidly catching up, and it is expected to be on par with lithium-iron technology within 18 to 24 months. This disadvantage is only really noticeable in high-performance vehicles like the Tesla Roadster. To fully understand how this is a big deal, let us talk about the difference between the lithium iron phosphate and lithium-ion batteries. In today's portable electronics, two types of batteries are used, lithium-ion and lithium iron phosphate. While they have some similarities, there are significant differences in terms of high energy density, long life cycles, and safety. Most people are familiar with lithium-ion batteries because they own a smartphone, tablet, or computer. Lithium iron phosphate batteries are gaining popularity in the manufacturing industries due to their low cost and high temperature stability. First, the lithium iron phosphate or LFP and lithium ion chemistry. Because both have a graphite anode, lithium ion can have two different cathode chemistries, lithium manganese oxide or lithium cobalt dioxide. It has 150 to 200 watt-hours of specific energy per kilogram and a nominal voltage of 3.6 volts. Its charge rate ranges from 0.7 to 1.0 because higher charges can severely damage the battery. Lithium-ion batteries have a discharge rate of 1. While the cathode of lithium iron phosphate is iron phosphate and the anode is graphite, it has 90 to 120 watt-hours of specific energy per kilogram and a nominal voltage of 3.20 volts or 3.30 volts. Lithium iron phosphate has a charge rate of 1 and a discharge rate of 1 to 25. What are the differences in energy levels? When comparing lithium ion and lithium iron phosphate, there are significant energy differences. Lithium ion has a higher energy density of 150 to 200 watt-hours per kilogram than lithium iron phosphate, which has a density of 90 to 120 watt-hours per kilogram. As a result, lithium ion is typically the go-to source for power-hungry electronics that drain batteries quickly. Lithium iron phosphate, on the other hand, outperforms lithium ion in terms of discharge rate. At 25 degrees Celsius, lithium iron phosphate batteries have excellent voltage discharges. As the capacity is reduced, the discharge rate has little effect on the lithium iron phosphate battery. As for the life cycle of each, the life cycle of lithium iron phosphate is 1,000 to 10,000 cycles. These batteries can withstand extreme temperatures with little degradation. They have a long life for applications that have embedded systems or need to run for extended periods of time before charging. The higher energy density of lithium ion makes it more unstable, especially in higher operating temperature environments. It has a life cycle of 500 to 1,000 cycles because the operating temperature of the electronics or working components can negatively impact it. Right now, it is unclear where Ford would mass produce these LFP batteries at this time, but China is currently a leader in the development and manufacturing of lithium iron phosphate batteries. LFP batteries are already very popular in China, where customers are more concerned with cost and durability than with absolute driving range. CATL, a Chinese battery giant with numerous manufacturing plants throughout China and one in Erfurt, Germany, currently supplies the LFP battery used in the Model 3 and Y. CATL currently manufactures batteries for a number of well-known automakers, including BMW, Honda, Volvo, and the Volkswagen Group, in addition to Tesla. One of the primary reasons why LFP batteries aren't widely produced outside of China, though, is a slew of patents that have allowed the country to corner the LFP market. It's also unclear at this point whether the addition of LFP batteries to Ford EVs will allow the Blue Oval to produce the vehicles more quickly, but we are willing to wait for however long, so long as we get the best. What do you think of this new innovation by Ford? Would you be willing to wait to get one of their newest releases that has an LFP battery? Let us know what you think in the comment section below. We hope you enjoyed this video. Do not forget to give us a thumbs up and subscribe for more.